In 2010, the Pella Amateur Radio Club started the PENS program, that stands for Pella Exploring Near Space, by which we fly student experiments into near space with a latex balloon, and then we track and retrieve these experiments for data processing. In 2017, we expanded this program to PENS-P, in which the P stands for PICO. This is in reference to PICO satellite, or a tiny satellite, by which we take a small device called a sky tracker, tie it onto a balloon, fly it up to 40,000 feet where it becomes buoyant, and then we let the balloon ride the wind as far as it can go. The sky tracker contains a GPS receiver, an amateur radio transmitter, a computer, and is powered by solar panels, which enables the students to track the PICO satellite on their computers or smartphones wherever it goes. Normally, we go into the classroom and expose students to earth science, where we talk about the troposphere, stratosphere, global position technology, amateur radio technology, and high-altitude ballooning. We would then fill a balloon with helium, attach the sky tracker, and go outside and fly the balloon. Then we go back inside and show the students how they can follow the sky tracker wherever it goes on their computers and smartphones. During the time of COVID-19, we go into the classroom via video conferencing, where we are able to sit at home and present live to the classroom our PENS program. We can see the students can see us, and everyone is safe. The students are given opportunities every 5 to 8 minutes to ask questions. We have made a video of filling the balloon so the students can see the precision that is necessary to do this. And then we bring a pre-filled balloon to the school and meet the students outside so they can launch the balloon and watch it fly out of sight. Believe it or not, in order to fulfill our goal of circumventing the Earth with our sky tracker, filling the balloon requires extreme precision. In order to do this, it requires a room with absolutely no air currents. The necessary equipment will include a precision gram scale, a helium tank with filler valve, an impulse sealer, a 50-gram weight, and our sky tracker. The first thing we need to do is to weigh our components. We want an accurate gram weight of the sky tracker, an accurate gram weight of the 50-gram weight, and it's not necessary for the flight, but we also want to know a precise gram weight of our balloon. Now it's time to start filling the balloon. We have calculated that we want exactly 7 grams of lift in order to achieve a float altitude between 40,000 and 43,000 feet. We have found that the most accurate way to put 7 grams of lift into a balloon is to measure negative weight. This is performed by taking the weight of the sky tracker, add 7 grams to that weight, subtract that from the weight of the 50-gram weight, attach the balloon to the 50-gram weight, set the 50-gram weight on the gram scale, and fill the balloon until it reads the calculated weight. For example, this sky tracker weighs 12.51 grams. The 50-gram weight weighs exactly 50.25 grams. 12.51 grams plus 7 grams equals 19.51 grams. 50.25 grams minus 19.51 grams equals 30.74 grams. That means that we fill the balloon with helium until the gram scale reads 30.74 grams. Then we can seal the balloon, and this is done with an impulse sealer. The balloon is made from space-age plastic, and the impulse sealer will seal the valve by melting a seam across the valve to seal it shut. We're going to melt 3 seams on the valve, and this should ensure that absolutely no helium will leak out during its high-pressure flight. The final step is to tie the sky tracker onto the balloon so that it cannot come off. When the sky tracker is secured, the balloon envelope is very carefully folded in half and placed into a truck for transport to the launch site.
Cooper, all the way up. 4, 3, 2, 1.
Fifth graders, are you ready?
Yeah!
Let's go. Let's count down from 10, okay?
T-minus 10.
10,
9, 8, 7, 6, 5, 4, 3, 2,
Following the flight, the students can go into the classroom where they can get on their computers or smartphones and track the sky tracker wherever it goes. If the students click on the balloon, a label comes up that gives real-time information about the balloon's speed, altitude, direction of travel, temperature, voltage from the solar panels, and how many GPS satellites it is receiving. Over the past years, teachers and administrators have proclaimed the positive impact that this project has had on hundreds of our students' lives. This project was made possible by the Pella Community Foundation and the Marion County Community Foundation, and we want to thank them for their financial support for helping to make this project a reality for our children. Thank you.